Hi, welcome back. In this video, we shall see about logarithmic differentiation. So, what exactly is the logarithmic differentiation is? Suppose we have some certain special cases of functions like u of x power v of x. For example, I do have a function x power sin x, or x power sin x plus tan x, or x power e power sin x. So, the logarithmic way of solving differentiation of these functions would be very easy than normal methods. So let y is equal to e of x. While solving using logarithmic differentiation, we take let y is equal to e power x power b power x. The next step would be applying logarithm on both sides. Log y would be equal to log of e power x plus v on v power x. So we know v power x comes to the front, so it becomes log y is equal to v power x into log of u power x. So now it's like differentiating two functions. I can differentiate both sides with respect to s so that I can obtain an option. Only the constraint here is both e of x and v of x should be positive functions, because logarithm is not defined for negative functions. That is only the concern we have. If not, the logarithmic differentiation can be applied for any functions of the form u power x plus v power x. So let me complete this. I got log y is equal to v of x times log of u of x. Differentiating both sides with respect to x, we get d by dx of log y is equal to d by dx of v of x into log of v of x. Differentiating both sides with respect to x. Simple. So we know the derivative of log is 1 by y, and derivative of y with respect to x would be dy by dx. So 1 by y into dy by dx should be equal to, these are two functions, so let it be u into v. So differentiation of uv would be u dash into log of e of x plus v of x into derivative of log of e of x derivative would be 1 by e of x into u dash of x. This will be the derivative of log of e of x. So from this, dy by dx would be v dash x log of e of x, or I can take even e of x LCM, e of x into v dash of x. Let me solve one two examples so that you get a very good idea about this. Don't worry by looking at these hard words or hard letters here. U of x into v dash of x into log of e of x plus v of x into u dash x upon u of x into y would give me the differentiation of the given function, which of the form e of x whole multiplied with y. This should be the differentiation of the function u power x power v power x. So dy by dx. So if you use logarithmic function, the TDS functions comes into be very easy functions. So let me give me an example and let's solve the exercise so that we get very good clarity on logarithmic differentiation. What is the logarithmic differentiation? Is the process of finding derivative using with the help of logs is the logarithmic differentiation, nothing else other than this. Good. So let me solve an example. Let me solve the same example, x power sin x, in this video so that you get idea about this. So take the function y is equal to x power sin x. I would like to find derivative of this function. So the first step would be apply log on both sides. So it becomes log y is equal to log of x power sin x. As you know, log a power m is m log a. This becomes sin x times log x. So it implies log y derivative is 1 by y into dy by dx is equal to sin x derivative is cos x into log x plus sin x into log x derivative would be 1 by x, so sin x by x. So it implies dy by dx is, y comes this side, y into, I can write this as x times cos x into log x plus sin x upon x. So you can replace y with x power sin x, so this becomes x power sin x times cos x log x plus sin x upon x. This would be the answer for the derivative of x power sin x. If you use logarithmic function, it becomes in 2 steps and it becomes very easy to. That is the reason we suggest to use logarithmic functions. Let me solve 2 more examples. I would like to find the derivative of x power y plus y power x is equal to a power x. So first step would be differentiating both sides. So d by dx of x power y plus d by dx of y power x is equal to d power dx of a power x. This should be our first step, d by dx of a power x. So take x power y function, let x power y u is equal to x power y. It implies log u is equal to y times log x. It implies differentiating now both sides with respect to x, 1 by y into du by dx is equal to y derivative is dy by dx plus dy by dx plus y by x. So it implies du by dx is u times dy by dx plus y by x. We know that u function is x power y, so I can replace this with x power y into dy by dx plus x power y, and I have y in the bottom, so it becomes x power y minus 1 into y. This should be the derivative of the function x power y. Okay. The next step would be find the derivative of y power x. Let v is equal to y power x. Again apply logarithm on both sides. So log v is equal to x times log y. Differentiating both sides with respect to x, we get log v derivative is 1 by v into dv by dx is equal to x derivative is 1. It becomes log y plus x by y into dy by dx. So it implies dv by dx is equal to v times log y plus 1, but v is y power x, so this becomes y power x into log y plus x by y into dy by dx. I can simplify it further. It becomes y power x log y plus y power x minus 1 into x into dy by dx. Derivative of a power x is a power x ln of a. It's on your right hand side. So replace x power y derivative, y power x derivative and a power x derivative in the given equation. X power y into dy by dx plus x power minus y, x power y minus 1 into y. So we have derivative of u power x, x power y plus derivative of y power x is equal to derivative of a power x. Is the function which we have there, which is derivative of a power x. But we got derivative of x power y as x power y into dy by dx plus x power y minus 1 into y. So derivative of x power y is x power y into dy by dx plus x power y minus 1 into y. This should be the derivative of x power y. Plus we got derivative of y power x is y power x log y plus y power x minus 1 into x into dy by dx plus y power x into log y plus y power x minus 1 into x into dy by dx, y power x minus 1 into x into dy by dx is equal to derivative of a power x derivative, we got it as a power x into ln of a. So let me take dy by dx, let me solve for dy by dx. So take dy by dx common. If I take dy by dx common, I get dy by dx is equal to x power y plus y power x minus 1 into x. This is what I get of dy by dx. So take rest of the terms onto the other side. So it becomes a power x ln of a minus x power y minus 1 into y minus y power x into log y. Therefore dy by dx is this complete thing upon x power y plus y power x minus 1 into x. This should be the derivative of the given function, which is a x power y plus y power x is equal to a power x. So it becomes a power x ln of a minus x power y minus 1 into y minus y power x into log y. This is the differentiation of the given function. Hope you are clear with this. Just go through this carefully, these 3 pages, so that you get an idea. Now let me solve an exercise based on NCERT class 12 book, complete logarithmic differentiation exercise, so that you get more idea about what exactly I would like to say here.